All right, so today we're going to cover Chapter 3, Section 3, but I do want to take a step back. I noticed something that the book is doing that I kind of would do it a little differently, so I want to back up just a little bit and look at our notes for special case derivatives. We've covered everything you need to cover, but I'm going to review it and I'm going to add just a little bit. So first of all, special case. They're the ones that should jump out. E to the x, ln, log, natural log, and a number raised to a base. So the first one is, what's the derivative of e to the x? E to the x. Okay, so anytime you see e to the x, you get e to the x. But it's a little deeper than that, and they don't really get into it. So what we talked about at the end of the class is, what if it's e to the something x? So if I had, let's say, e to the 3x, what would the derivative be? If I had e to the 3x, what would the derivative be? So I want to focus on that one because step one, you would rewrite it times the derivative of the exponent. What's the derivative of 3x? What's the derivative of 3x? 3. So your final answer would be 3e to the 3x. So not that it's complicated, but it's a little bit more than what they taught, which is e to the x is e to the x. Great, get that. But if you have something like 4x, you would rewrite it, e to the 4x times the derivative, which is 4. Now, this only works if it's something x. So if it's x squared or x cubed, that's a whole other story. We'll learn that later. But I just wanted to add, in addition to the derivative of e to the x, which is e to the x, if it was e to the 3x, you rewrite it, derivative of the exponent, so you get 3e to the 3x. Are we okay? We went over that. We went over natural log. So just to do another example real quick. What if I had 5 ln of x? Well, what would the derivative be? What happens to the number in front? Stays in front. And what's the derivative of ln of x? 1 over x. So your final answer would be 5 over x. Bless you. And again, you have it, all the special cases in front of you, so you know what to do. Okay? If we had log, let's say we had f of x equals log, pick a number, 6. Log base 6 of x, you look at your formula, what would the derivative be? What would the derivative be? Follow the formula. 1 over ln of 6 times 1 over x. So I'd probably write 1 over x ln of 6. So again, for all the special cases, we talked about where they came from and all that. You have a format, follow the format for the derivatives. And then the one I really want to go over is 4. Again, they don't take it that extra step. And what I mean by that is, what we learned is if you have a number raised to an x, how do you take the derivative? Step 1, rewrite it. Step 2, ln of the base. But there actually is a third step. And that third step is derivative of the exponent. And because what's the derivative of 1x? What's the derivative of 1x? 1, so you don't really see it. So, and again, they teach it later, but let's say we had 3 raised to the x squared minus 2x plus 4. Let's say it was a little more complicated. So, to find the derivative, there's actually 3 steps. Step 1, rewrite it, which is what we did last time. Step 2, times ln of the base, which is what we did last time. But the part they didn't talk about, because the derivative is 1, is that step 3. Step 3 is derivative of the exponent. And what's the derivative of x squared? 2x. And what's the derivative of minus 2x? Minus 2. And the derivative of 4? That would be the answer. So I did want to focus here that if I had a number raised to a little bit more than x, 3 steps. 1, rewrite it. 2 ln of the base, and then 3 derivative of the exponent. And they kind of make sense. I got to take the derivative of all of them. I rewrite it, ln of the base, but you haven't taken care of that exponent. That's what that last step is. Okay? And you have these. They're in front of you. When they show up, look them up. Okay? Any questions on those special cases? And you have some examples. Okay? So, today we're going to step away from special cases, but we're going to start learning some techniques. So all of this is based on you know how to take a derivative. You know how to take a derivative. What we're going to learn today is how to take a derivative of 2 things being multiplied and how to take a derivative of 2 things being divided. Okay? The good news is there's a formula. Follow, 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 you get the answer, and prove why they work. Okay? So in section 2.5, we found the derivative of a sum is the sum of the derivatives, and the derivative of the difference is the difference of the derivatives. So if I have a long set of terms, and they're all being added or subtracted, you just take the derivative of each one. But when 2 things are being multiplied or divided, things change. So in this section, we consider if similar properties hold for multiplication and division. We first test the theory. So if I have 2 things being multiplied, let's say I have function 3x plus 2 and the function 2x minus 3, could I simply take the derivative of each one? And the answer is no. You can't just take the derivative of each one and multiply. This kind of proves why. So if I take the product of them, I multiply them, and then take the derivative, is that the same as taking the derivative of each one? And the answer is no. So all we're learning from this slide is when you have 2 things being multiplied, do I just take the derivative of the first one, take the derivative of the second one, and then multiply it? And the answer is no. It doesn't work that way. It's not that simple. Okay? So that's what that slide's saying. So your question is, how do you do it? And the answer is, we have a formula. Okay? The derivative of the product of 2 functions is first times the derivative of the second plus second times the derivative of the first. What does that mean? Let me show you some symbols. Okay? And we'll do examples, don't worry. But here's the formula of how to take the derivative. First of all, let's call the first one f of x. Let's call the second one s of x. So do we have 2 things being multiplied? Yep. How do you do it? Step 1, leave the first one alone. Just rewrite it. What is s prime of x? What does that mean? What does that prime mean? Derivative. So leave the first one alone, take the derivative of the second one. Leave the first one alone, take the derivative of the second one. Plus, it's always a plus. Leave the second one alone, just rewrite it, times what? The derivative of the first one. So think of it this way. First one, rewrite it, derivative of the second, plus leave the second one alone, derivative of the first. And we'll do a bunch of these, don't worry. But that's the formula. When you have 2 things being multiplied, you leave the first one alone, just rewrite it, derivative of the second, plus leave the second one alone, derivative of the first. And this is another way to write it here. Okay? So I got to prove to you that it works, and we're going to do it. So we're going to do this problem. Number 1, we're going to do the product rule, and then we're going to prove that it works. So let's go to a piece of paper, and let's go nice and slow to explain all this. So step 1. Let's identify, do we have 2 things being multiplied? Do we have 2 things being multiplied? The first thing is 2x squared. The second thing is 3x to the 4 minus 2. So can we all agree and identify that we have 2 functions being multiplied? We have 2 things being multiplied. Are we good? Make sense? So when you have 2 things being multiplied, we follow the product rule. And the product rule says leave the first one alone times the derivative of the second one plus leave the second one alone times the derivative of the first one. Okay? So this is the product rule. This is what we found. So I'm going to go nice and slowly. Stop me if you have any questions. I'm going to go nice and slowly. Stop me if you have any questions. Okay? So, to take the derivative, let's go nice and slowly. What does this f of x tell me to do? It's the original first one. Are we okay? Next, what does s prime of x mean? Multiply by the derivative of the second one. What's the derivative of 3x to the 4? Good. And what's the derivative of -2? Stop there. Plus. Any questions so far? Any questions so far? Now, plus, what does s of x mean? The original second one times, what does f prime of x mean? Derivative of the first one, which is 4x. Stop there, take a little notes, do what you need to do, but that's it. When you have two things being multiplied, that's what we follow. Any questions on how I did that? Now you already know, am I going to leave that as my answer? What's the next step? Simplify. 2 times 12 is 24. X squared times x to the third is x to the fifth. I can distribute that and say plus 12 x to the 5 minus 8x. Anything else I can do to clean it up? 24 x to the fifth plus 12 x to the fifth is 36 x to the fifth minus 8x. Final answer. So, number one, you got to follow product rule. Number two, you got to know your algebra to clean it up. You'd be surprised how many people do the derivative right, but they mess up the algebra. Questions there? So, how do I get 24? 2 times 12 is 24. X squared times x to the third is x to the fifth. So I put this together. This one I distributed. 3 times 4 is 12. X4, x1 is x5. 2 times 4 is 8, x. And then those are like terms. Are we okay? Now, here's the deal. I'm the person in front. So you just copy everything down, and you're like, okay, product rule. You don't have to prove anything. You're the person in front. It must be true. No, I got to prove to you that it works. So let me real quickly prove to you that it works. So right now, I'm telling you that the answer is 36x to the fifth minus 8x. Well, let me prove to you that it works. So here's the original question. And maybe somebody in the class was thinking, hey, that's a lot of work. Couldn't you simplify first? Didn't you tell us that if it looks weird, clean it up first and then take the derivative? Yeah, I could have sat here and rewritten it as 6x to the 6 minus 4x squared. And if I cleaned it up first, guess what? No more product. No more product rule. I could have just taken the derivative. So what's the derivative of 6x to the 6? And what's the derivative of minus 4x squared? Now the problem is you're saying, cool, let's do that. That's not my point. My point is to prove, does product rule work? Does product rule work? Yes. Now you're like, I don't want to do product rule. I want to do this. I want to do this. Believe it or not, sometimes it's actually longer to clean it up, make sure it's simplified, then take the derivative, than to just do product rule. So bottom line, you need to know product rule. Bottom line, you need to know product rule. The good news is you can check it. The good news is you can check it. Okay? So let's stop there a second. Any questions on product rule? Okay? So now it's your turn. I'm going to kind of go off the notes a little bit, but we'll come back to it. Because my focus today is teaching you product rule and teaching you quotient rule. We're going to get into a few other things, but the focus of today is product rule and quotient rule. Focus of today is product rule and quotient rule. So number one, do we have two things that are being multiplied? Do we have two things that are being multiplied? Yes. So what are you going to follow? Product. Again, follow product rule, nice and slowly, carefully, and then simplify. You need to simplify. You need to simplify. And it all goes back to derivatives. It all goes back to derivatives. And if you're fast, simplify first, then take the derivative. You can see if it works. You can always check it. You can always check it. But it all goes back to derivatives. If you don't shake down derivatives, then you may have some issues. Say about 1 more minute, make sure you simplify, make sure you're tuning up, all that stuff. Okay, so can we agree that we have two things that are being multiplied? So that means we're going to use product rule. Product rule says leave the first one alone times the derivative of the second plus leave the second one alone times the derivative of the first. So there's the rule. We're just going to work it out right below. So to find the derivative of two things being multiplied, leave the first one alone. What's the derivative of the second? 2x. Stop there. Any questions? Derivative of x squared is 2x, derivative of 6 is 0. Gotta know our derivatives. Questions there? I like how we're helping each other. Then plus, leave the second one alone, just rewrite it. Derivative of the first. What's the derivative of the first one? Derivative of 2x is 2, derivative of negative 9 is, stop there. If you got that, you got product rule. We're not done, because we need to clean it up, we need to simplify it. But any questions so far? That's product rule. Now again, I can put in decimals, negatives, fractions. I can throw in whatever derivative, special case. I can throw in any derivatives I want. The product rule stays the same. Okay? Now the next step is to clean it up. This will be 4x squared minus 18x plus 2x squared plus 12. And then combine like terms, algebra, you get 6x squared minus 18x plus 12. That would be your final answer. Now, if I wanted to check this, I would clean up the top and then take the derivative. It should be the same. I'm going to go ahead and do that. You may or may not have done that, but just to show you that it does work. If I had gone over here, distributed, I would have got 2x to the third plus 12x minus 9x squared, bless you, minus 54, bless you, which that cleans up to 2x to the third minus 9x squared plus 12x minus 54. So what if I had cleaned up first? What if I had cleaned up first, then took the derivative? I would get 6x squared minus 18x plus 12. You would get the same answer. But you need to know product rule. You need to know product. Are we okay? Questions? Now again, I can throw in a decimal, a fraction, a negative. I can throw in a ton of stuff in here. But product rule is going to stay the same. Okay, and we'll practice more. I'm going to teach a little something. I'm going to do quotient rule, then we'll come back and we'll practice both. So, I'm going to go to the notes, but I don't want you to freak out. I'm going to go to the notes. I don't want you to freak out. Let's go through the slides together. But again, this is important, but not our focus today. This is important, but our focus is just learning product and quotient. This one says, find the equation of a line tangent to the graph of f of x at x equals 3. Now that sounds a lot, because we're going to focus more on applications and not as much on the tangent line. But anytime it says tangent line, all that means is take the derivative. When you take the derivative, you're finding slope. When you take the derivative, you find slope. So let's just walk through the slides. The slide's going to say find the derivative. So we take the original first one times the derivative of the second, plus the original second one times the derivative of the first. We work it out. Then we take that 3 and plug it into the derivative, and we get 12. So what we're learning here is how to take the derivative. They want to know the equation of the tangent line at x equals 3. So when you take the derivative, you're finding the slope, rate of change. You plug 3 into the derivative, you get 12. What does that mean? That means your slope is 12. At x is 3, the slope is 12. Okay? But the question said the equation of a line. So we know that we're finding 3. We know that the slope is 12. So I take 3, plug it into the original, take 3, plug it into the original, and that gives us the point 3 comma negative 45. So if we have the point 3 comma negative 45, and we have the slope, which is 12, We plug into y minus y1 equals m times x minus x1. Plug in the point, plug in the slope, and we get the equation of the tangent line, y equals 12x minus 81. This is important, don't get me wrong, but our focus is not on finding the equation of a tangent line. Our focus is going to be more on word problems applications, not just finding the slope of the equation of a line of a tangent line. But that's how you would do it. Okay? And then it says find the values of x where the tangent line is horizontal. That's where the slope is 0. So if I take the derivative, set it equal to 0, and solve, clean it up, which we did, factor out the 6, factor, we get 1 and 2 as our solutions. So the slope of the tangent line is horizontal when x equals 1 and x equals 2. Again, important stuff, but our focus is on word problems and doing more than just finding when the slope is horizontal, finding more than when the slope is 0, things like that, but that's where it would happen. Okay? And we'll get back to all that. But now we're going to focus on quotient. Let's say we had two things being divided. For example, we had x to the 5th and x squared, and I want to find out what would be the derivative of x to the 5th over x squared. Well, we can't just simply figure out the derivative of the first one, figure out the derivative of the second, and divide it. That will not work. Just like last time, finding the derivative multiplied will not work. So, since that won't work, we have a formula for finding derivatives. And don't be afraid, the formula is this. Now, it looks long, but let me explain it. So, first of all, we're going to call the top, which is the numerator, t of x. We're going to call the bottom b of x. Okay? When you have two things divided, this is what you follow. Now, it looks crazy, it looks complicated, but we're going to go through it nice and slowly. Remember, prime means derivative, no prime is the original. So when I have two things being divided, how do you take the derivative? You do, what is this one? The original b times the derivative of t, the top. So the original bottom function times the derivative of the top function minus, yes, it is a minus. It's part of the formula. What's this next one? The original top times the derivative of the bottom all over the original bottom squared. Okay? Now again, it looks crazy, it looks weird, but you'll have it in front of you. You just go step by step and follow what it says. So when you have two things being divided, this is what you follow. Original bottom times the derivative of the top minus original top times the derivative of the bottom all over the original bottom squared. Remember, the top is numerator, the bottom is denominator. Okay? So we'll just follow it. Says the same thing. It's called quotient rule. Another way to write it. Let's do an example. Okay? So, nice and slowly. If you have x squared over 2x minus 1, do we have two things being divided? Do we have two things being divided? Yep. So what do we follow? We follow quotient. So when we have two things being divided, we use quotient rule. Quotient rule says the original bottom times the derivative of the top minus the original top times the derivative of the bottom all over the original bottom squared. So all we need to do is nice and slowly follow this formula. All we need to do is nice and slowly follow this formula. Okay? So let's go nice and slowly, and we're going to do piece by piece. Okay? So what is the very first thing we're going to do? The original bottom, which is what? 2x minus 1. Any questions there? The original bottom, 2x minus 1. times, what is t prime of x? The derivative of the top, the derivative of x squared is 2x minus. Stop there, make sure everything makes sense. Stop there, make sure everything makes sense. Next, the original top. What's the original top? X squared times what? What does this say? B prime of x? Derivative of the bottom. What's the derivative of 2x? 2. Derivative of minus 1? 0. Stop there. Any questions? Any questions on how I got the numerator? Original bottom times the derivative of the top minus original top times the derivative of the bottom. You gotta know your derivatives, gotta know your derivatives. All of this over what? B of x, what's that? The original bottom squared. Stop there. Make sure everything makes sense. Make sure everything makes sense. Make sure everything makes sense. Now, I want you to simplify the numerator only. Simplify the numerator only. Clean up the numerator, leave the denominator alone. Simplify the numerator only. It's basic algebra. All of you know how to do it. Clean up the numerator. You'd be surprised how many people make little mistakes. So, to clean up the numerator, distribute the 2x, you get 4x squared minus 2x squared over 2x minus 1 squared. And then your final answer will be 2x squared minus 2x over 2x minus 1 squared. And that would be your final answer. Algebra, algebra, algebra. That's why we spend so much time in Appendix A in Chapter 1. You gotta know your algebra. Any questions on quotient? Questions on quotient? Yep. Yeah, that's a good question. Would it make sense to do 2x minus 1 times 2x minus 1, foil, and clean it up? Would it actually be cleaner at the end? Probably not. So I would, and I'll be pretty specific on the test, like simplify numerator, simplify denominator, things like that. But if I did it, would it help? No. I don't think it would be any cleaner, any helpful. It would actually be good the way it is. Okay? So let me give you one to work on. Let's say we have, let's just use a different letter now. Let's say f of t. Does it matter what letter I use, really? No. It could be any letter. Let's just practice using a different letter. Okay? So here's the function. Do we have two things that are being divided? So we're going to use quotient rule. Remember, original bottom times the derivative of the top minus original top times derivative of the bottom all over the original bottom squared. And just like last time, find the derivative and simplify the numerator only. Find the derivative and simplify the numerator only. If you have questions, let me know. Look around. Today we're learning product rule and quotient. So in chapter 3, you should already know derivatives. We have the special cases, and now we have product rule and we have quotient. We have product rule and we have quotient. You gotta know your derivatives. You gotta know your derivatives. You gotta know your derivatives. And we haven't done anything weird. No decimals, no fractions, nothing, no square roots, no special cases. We're keeping it simple, so we're gonna focus on the quotient. Go step by step by step. Then some of you are gonna find that the algebra is the problem, or all parts of the problem. Original bottom times top, all over the original bottom square. Nice and slowly. Make sure there's no mistakes. Simplify the account.
Right? Oh, I'm just saying, I thought I messed up, yeah.
The little things are yes.
That's why it's like that. And the coach is on it.
It's actually a little more complicated. We worked it out with the definition. It's a lot. So that's why it's kind of like that's kind of what you said, like you double and triple.
So it's the same thing.
Yeah.
So it's just a pattern that develops. Good question. Hey, about 1 minute, I'll write the derivative part just to see if you got it correct. Then you got to check the algebra.
like, I think, that don't be no. It's an before you close it.
Okay, so let's make sure we did the derivative correctly. We have the original bottom, t3 minus 1, times the derivative of the top. Be careful. What's the derivative of t squared? 2t. What's the derivative of minus t or minus 1t? Minus 1. We messed that little minus 1 up. What's the derivative of 5x? 5. Derivative of 10x? 10. 7x? 7. What's the derivative of 1t? 1. Minus the original top times the derivative of the bottom. What's the derivative of t to the third? 3t squared. What's the derivative of minus 1? 0. All over the original bottom squared. So if you made a little mistake there, go back and check it, and now simplify the domain. Now simplify the domain. Detail. One little mistake will throw it off. It all goes back to derivatives, and it goes back to algebra. Odds are you're not struggling with a quotient rule. You're struggling with derivatives, or you're struggling with algebra. That's the issue. Most likely not the quotient. People can follow a formula pretty well. It's making those little mistakes. Okay, I'm going to go ahead and work it out as you're working it out. When you're done, look up. But at this point, I'm not trying to be mean. It's algebra. All of us, we did the time on Appendix A, which we did our best to review it, but you've got to know your algebra. And I'm pretty confident that you do. It's usually little mistakes. And it's being careful when you do that. So look up just for a second. Here's a common mistake people make. We have to distribute the minus, and we have to distribute the 3t squared. We have to distribute both. So I'm going to save a little time by putting minus 3t squared. So I'm distributing the minus and the 3t squared at the same time. Those are little things to help me reduce mistakes. I don't have to. Have it? I just moved this in front, so I can do this at once. Instead of distributing the negative and then distributing the 3, I did it all at once. And that, again, will reduce my chance of making a mistake. So when you're done, 2x to the 4 minus 3x to the 4 is negative t to the 4. Okay, I forgot something, didn't I? Hold on. Oh, let me back up. Let me do this again. I started jumping to the other one. So again, I moved the 3t squared in front. That will help me out when I get to that point. And so let's start from here. So I moved the 3t in front so I can do that at once. And slowly, t3 times 2t is 2t to the 4. T to the third minus 1 is minus 1t to the third. Minus 1 times 2t is minus 2t. Minus 1 times minus 1 is plus 1. Again, all of you know how to do that. Be very, very careful. Negative times positive is negative 3t to the 4 plus 3t to the 3rd all over t to the 3rd minus 1 squared. And again, careful, careful, careful. Then 2t to the 4 minus 3t to the 4 is negative t to the 4 minus 1t to the 3rd plus 3t to the 3rd gives you plus 2t to the 3rd plus 2t, sorry, minus 2t plus 1. Questions there? All over t to the 3rd minus 1 squared. Now, as you're writing this down, this is going to be the hard part. Is your issue quotient rule, following the formula? Is your issue derivative, or is your issue algebra? There's 3 things going on. And as I told you in the beginning of class, most people have problems with algebra, algebra, algebra. All of you can do it, but you got to be careful. See how I made one little mistake and it threw us off? We got to go nice and step by step and be careful as we go through. We okay? So again, quotient rules, following the formula. You need to know derivatives, and you got to know your algebra. Those are the 3 things. Most people don't struggle with the formula. Most people struggle with the algebra. Most people struggle with the algebra. Okay? So let's try a word problem. We love word problems, but it's the same old, same old, same old that we've been doing. Okay? So I want you to read it first and write down what is the input, what is the output. Every word problem, we should start with what is the input, what is the output. Every word problem, we should start with what is the input, x, what is the output, y. The total sales S in thousands of games of a video game T months after the game was introduced is given by S of T equals 125 T squared over T squared plus 100. So, what is the input in this example? What's the input? What am I plugging in? Time and months. Okay. What is my output? Sales in thousands. And sales of what? What are we selling? Video game sales. Okay, so that's number 1. Number 2, when you look at the function, is this going to be product rule or quotient rule? It's going to be quotient rule. Now, like we did last time, here's what I'd like you to do. I'd like you to first find the derivative. Take your time on that. Then we're going to plug 10, which is 10 months, into the original, see what you get. Plug 10 into the derivative, see what you get. So y1 is the original, y2 is the derivative, y3 is the derivative in the calculator, just like we did before. It's the same old stuff. It's just now we have quotient rule. Now we have quotient rule. So find the derivative. Once you find the derivative, we're going to plug 10, and we're going to use the calculator to verify everything at 10. First, take the derivative, follow the formula. Careful. Quotient. Get the derivative first. Get the derivative first. Now keep in mind, I'm keeping these pretty straightforward. There's no decimal, there's no fraction, there's no square root, there's nothing weird going on. I can add all of those to the derivative. So we can be pretty straightforward for now. Just to make sure we understand quotient, just to make sure we understand product. And then once you get it, y1 is the original, use parentheses. y2 is the derivative function, use parentheses. And then y3 is the derivative in the calculator, which is what we've been doing for all of them. This is the main focus. Using derivatives to solve problems. This one happens to be a quotient rule problem. I'll give you a couple of minutes and we'll check the derivative first. Oh. All right, let's do the derivative first. Let's see how we're doing. Again, the part you don't want to hear is, it's not quotient rule. Quotient rule is not the hard part. It's derivatives and algebra. And for most of you, it's algebra, right? So that's not what we're worried about. This is calculus. This is an algebra class. So let's be careful. So the derivative is going to be the original bottom, t squared plus 100, times the derivative of the top, which is 250t. Did we get that right? If that's wrong, everything's wrong. One little mistake. If you don't know how to take a derivative, That's your problem. Then minus original top times the derivative of the bottom. What's the derivative of the bottom? 2t. Right? All over the original bottom square. So stop there. Did we do the quotient rule correctly? Did we do the quotient rule correctly? Now I'm not done because I need to simplify the numerator. But if that part's wrong, everything else is wrong. Are we okay? Now, let's clean up, which is the algebra part that we shouldn't be too worried about. We're going to get 250 t to the third plus, what does that give you? 25,000 t. Now, again, this is the part where a lot of little mistakes happen because I have a negative and I have these. So 125 times 2 is 250, negative 250 t to the third. Negative 250 t to the third all over t squared plus 100 squared. And then what ends up happening? So this actually is not as ugly as you think. It's 25,000 t over t squared plus 100 squared. If the derivative is wrong, then everything else is going to be wrong. Okay? So I'm going to give you some time. Make sure this all makes sense. Y1 is the original. Y2 is the derivative. Use parentheses in your calculator. Be careful, be careful, be careful. Use parentheses. Now, Y2 and Y3 should match when you plug in 10. When you plug in 10. So remember my original was 125 t squared over t squared plus 100. That goes in Y1, derivative in Y2, and Y3 is the calculator. Let's see what happens when we plug in 10 into the original, and what happens when we plug in 10 into the derivative. It's the same old, same old, same old. But again, you need to figure out where are you having trouble. Is it the quotient rule? Is it the derivative? Or is it the algebra? Make sure Y2 and Y3 match and write the sentence. Write the sentence. That's the part I'm working on, is what this stuff means. You're stressing about algebra. I'm past all that. All right, so let's see how we're doing. I'm going to go to my calculator. Be very careful how I type this in. So I go to my calculator, I go to Y1, turn off my plots, just make sure I have a clean calculator. I'm going to put 125x squared divided by parenthesis x squared plus 100. enter, that's my original. Y2, 25,000 x divided by parentheses, x squared plus 100 squared. And then in Y3, math 8, x, y1 is vars, y vars function, y1, x. Now again, I understand algebra mistakes happen, derivative mistakes happen. That's why you have the calculator to check everything. So when I go to the table and plug in 10, which ones should match? Y2 and Y3. And if they don't match, your derivative's wrong, or you typed it in wrong, or some issues there. That's going to make you feel like, oh, I did it right. I know, I can check. You have some way at least to know if you did it correctly. So when you plug into the original, you get 62.5. When you plug into the derivative, you get 6.25. Now, what I'm trying to focus on is what the heck are we doing this for? What's the point? Well, at month 10, video game sales is 62.5 thousand games. So I've been selling this game for 10 months. After 10 months, what's my total sales? 62.5 thousand games. That's what plugging into the original means. Okay? And then the big point, why are we doing this stuff? What's the whole point? Am I going to sell that many games for the rest of my life? No. Sales is changing. Sales is changing. What's going to happen next month? What's going to happen next month? So, at month. What it is?
Yeah.
Is that a phone or is that the speaker? Okay. So at month 10, video games sales these video games are flying off the shelves in alerts. Is it increasing or decreasing? How do you know it's increasing? It's positive. 6.25 what? Thousand games, and we already know derivatives better be what? 1,000 games per month. Good. So, what does this mean? My business, I've sold 62,500 video games. Next month, I'm expecting to sell an additional 6,250. So to prepare for that, I got to get my factory ready and have 6,250 games ready to go. Okay? But here's my hope. My hope is you look at this and you're like, isn't this the same stuff we've been doing? Yeah. Y1's the original. Find the derivative. Check it. Write in the sentence. It's all the same stuff. The only thing that's new is could be quotient rule. Could be product rule. Or it could be a special case. So chapter 3 is really the same old, but we have special cases now, we have product rule, and we have quotient. We have product rule, and we have quotient. Okay? Let me just double check. They added one more question. Oh. The only other question I can ask is, just to make sure you understand, right now I've sold 62,500. I'm planning on selling an additional 6,000. So if I want to estimate month 11, what do I do to those two numbers? Add them up. Right now I have 62,500 sold. I'm planning on an additional 6,250. If I want to predict month 11, you take what you have now and what you plan on selling and add them up. Okay? Let's stop there.